Right. So now we finished 2004 past paper calculation based questions. Now we'll go on with the 2005 MCQs. Right. So 2005 MCQs. So we have the 23rd MCQ, which is the general based chemistry based question. It's a general based chemistry question. So when I say general chemistry, you guys know it is about unit 3. So let's see the question. So NaOH reacts with urea as follows. So now they have given the reaction of urea with sodium hydroxide. So 2 sodium hydroxide, 2 moles of sodium hydroxide is required to react with 1 mole of ammonia, 1 mole of ammonia to produce sodium carbonate along with 2 moles of ammonia gas. This is the equation that they have given. So it is totally balanced right now. 0.6 grams of urea is reacted completely with 25 centimeter cube of 1 mole decimeter minus 3 NaOH. Now they used 0.6 grams of ammonia. They have given the relative molecular mass of urea to urea, which is 60 gram mole minus 1. They have given the concentration 1 mole decimeter minus 3, and they have given the volume that is used here. So we have 25 centimeter cube that is being used up. Right. At the end, all urea was expelled by boiling. Right now, after the reaction, we have some amount of urea produced within the solution. So urea can be expelled after by boiling, right? So then we have certain residues of the reaction which is there, and the question they are asking is the volume of 0.5 mole decimeter minus 3, the concentration of HCl necessary to neutralize the resulting solution. Okay, now see here, we have to find initial moles. So initial moles of urea and ammonia. So we have 1 mole decimeter minus 3 into 25 into 10 to the power minus 3 decimeter cube. So we have around 25 in 10 to the power minus 3 moles. Same way, here we have N, which is equal to W over capital M, the given mass over the relative molecular mass. So we will get N is equal to 0.6 grams divided by 60 grams mole minus 1, which is equal to 10 into 10 to the power minus 3 moles. Actually 0.01 that I have converted to 10 to the power minus 3. It will be better to solve the calculation here. Let's see the reacting moles. Reacting moles. So when all the urea is being reacted, so minus 10 into 10 to the power minus 3 moles. Here 1:2 ratio. If 10 is there, here 20 has to be reacted. That's the thing here we are doing. So minus 20 into 10 to the power minus 3 moles. Over to the right hand side, we have the products sodium carbonate and ammonia. So here we have 1 mole ratio. So 10 will be formed. So 10 into 10 to the power minus 3 moles. Along with that, we have twice here. So 1:2 ratio. So 20 into 10 to the power minus 3. 20 into 10 to the power minus 3 moles here. As a result, in the remaining moles, what we're going to have is, right, we have 5 into 10 to the power minus 3 moles, here 0, then 10 into 10 to the power minus 3 moles, and 20 into 10 to the power minus 3 moles here. See here, what they are doing is now they are boiling this up. They are boiling the resultant solution. In the resultant solution, we have some amount of NaOH remaining, and some amount of sodium carbonate. Some amount of sodium carbonate is also released, right? Some amount of sodium carbonate is also formed along with some ammonia, right? Now you're going to supply heat to boil the solution. While boiling, this ammonia will be completely evaporated as ammonia gas, right? As ammonia gas. So what do we remain here is, we have in the resultant solution we have sodium hydroxide and sodium carbonate. Now see the question. Now they have asked the volume of 0.5 mole decimeter minus HCl required to neutralize the resulting solution. So in a resulting solution we have sodium hydroxide and sodium carbonate. Now see here, sodium carbonate that was formed is actually 10 into 10 to the power minus 3 moles. Here we have the remaining of 5 into 10 to the power minus 3 moles. So in order to find out the volume, you need to know the total number of moles that is required for the HCl to completely neutralize the solution. Neutralizing means there should be no base, no acid, right? Neither of them should not be present within the solution. So when sodium hydroxide reacts with HCl, it forms 1 mole of water and we have 1 mole of sodium chloride. Same way for sodium carbonate, when it reacts with HCl, now here they didn't give any indicator or something. If they have used certain indicator, the products may vary. If they use phenolphthalein, right? Phenolphthalein. If there is phenolphthalein as the indicator, at the end point you will get sodium bicarbonate aqueous with some amount of sodium chloride form. If they use methyl orange, right? They use methyl orange. If they use methyl orange, here you will get sodium chloride, 2 moles of sodium chloride, 1 mole of carbon dioxide and 1 mole of water. They didn't give any indicators over here. As a result, what you have to do is, you can directly go with this reaction. No harm. Directly go with this reaction. So you can neglect this one. They didn't give any indicators over here. That's what this one means. So you need to completely neutralize them, right? There should not be anybody remaining here. Since they did not give any indicators, you can consider this reaction over here, right? So you can directly find out their number of moles. So here 2 moles will be there. So see here, we have 5 into 10 to the power minus 3 moles of NaOH. Here we have 10 into 10 to the power minus 3 moles of in sodium carbonate. Now this is 1:2 ratio. So in order to completely neutralize them, you need around 20 into 10 to the power minus 3 moles of HCl. Same case, 1 mole of sodium hydroxide need 1 mole of hydrogen chloride. So This is 1:1 ratio. If 5 into 10 minus 3 moles are required, then here also 5 into 10 to the power minus 3 moles of HCl is required. So the total number of moles of HCl required is, right? So the total number of moles of HCl required is, right? Let me raise this part, right? So the total number of moles HCl required to neutralize the resulting solution is equal to, here you have 5 and then you have 20. So 5 plus 20 into 10 to the power minus 3 moles, it is equal to 25 uh, 25 into 10 to the power minus 3 moles, right? This much of moles are required. Now the question is not yet in, right? They have asked the volume of HCl that is required. So volume of HCl required, volume of HCl required is equal to N is equal CV. So volume is equal N over C. So 25 into 10 to the power minus 3 moles divided by 0.5 mole decimeter minus 3. Now check the answers. They have given all in centimeter cubes, right? We have in decimeter cube. So by simplification, we'll get 50 into 10 to the power minus 3 decimeter cube. So if you multiply this by 1000, you will get centimeter cube, right? So you will get 50 centimeter cube. 50 centimeter cube, which is the fifth answer here, right? Fifth answer, right? Fifth answer is the answer over here, right? 50 centimeter cube. So, okay, here one thing, most of the students will get mistake here because they will not consider the number of moles that was formed with the sodium hydroxide and with the sodium carbonate. So most of them will think that there is only ammonia in the solution just by reading verbal problems maybe. So some of them will find the answer to be less than 10 centimeter cube. Actually, I just found out around 40 centimeter cube will be the answer if someone who doesn't have a lack of knowledge in their training statements. So be careful. They ask the required solution of HCl for the resultant solution. So they said if they are boiling the solution, they said that they are boiling the solution. So as a result, what will happen? Ammonia will be released due to the decomposition of ammonium hydroxide, right? So therefore, fifth answer is the correct answer. Note down all the points that I have given in the previous MCQ also, right? So we'll see you in the 26th MCQ. So we'll see you in the next video.